So now so let's go through it a little bit slower here. Amazon's US East region powers a massive chunk of the internet, and when it failed, the cascading impact was immediate and brutal. The outage started with DynamoDB, Amazon's managed NoSQL database service that millions of applications depend on for critical data. What makes this terrifying is that companies specifically chose AWS because they're told there's no single points of failure. So in architecting systems for a lot of years, the sales pitch is always about redundancy, failover, and resilience. The irony here is thick. A system designed with multiple independent components failed because those components weren't actually independent. This exposed the fundamental flaw in trusting any single cloud provider architecture claims without verifying them first. Now, the root cause was embarrassingly simple: a race condition in AWS's automated DNS management system. For those who are unfamiliar, a race condition happens when two processes compete to update the same resource and the timing determines the outcome. In this case, unusually high delays in one DNS component caused another component to think all the IP addresses had disappeared. The automated system then it did exactly what it was programmed to do. It deleted what it thought were stale DNS records. Except those records weren't stale, they were actually active IP addresses for critical AWS services across the region. So after a long time in software, I can tell you that race conditions are notoriously difficult to catch in testing because they only appear under specific timing conditions. Now, once the DNS records were wiped, AWS services couldn't find each other. So the problem is they couldn't even log in the systems to get them to talk to each other. So imagine trying to make a phone call when the phone book when all your contacts disappear. That's essentially what happened here, right? DynamoDB's regional endpoints became unreachable first, triggering API errors across thousands of applications. Services that depend on looking up other services via DNS started failing in cascading waves. EC2 instances couldn't launch because the control plane couldn't resolve the addresses it needed to provision new servers. So networking components that relied on DNS for service discovery started routing traffic to nowhere. The failure spread throughout AWS's infrastructure like a virus, each failing service taking down the service that depended on it. So EC2, Lambda, ECS, EKS, Fargate, basically every major compute service started experiencing failures because all of their DNS records were zeroed. Companies running containerized applications watched their entire infrastructure become unresponsive. Serverless functions that normally scale automatically were just gone, unable to process requests. The cascade happened faster than AWS engineers could react because automated systems kept trying to fix the problem by making them worse. So I built distributed systems, and this is a nightmare scenario when your automated recovery systems become part of the problem. The cascading failure lasted several hours, because fixing DNS issues requires careful manual intervention, and you just can't restart everything, right? There's no one computer to restart. If you like this clip, make sure you check out the full Startup Hack Live video here because we've got lots more for you today.